Okay, so the first change in the power supply is I've added another short length of the larger shrink. And what you're going to do is you're going to still have a segment of shrink that gets you through the top plate from the transformer. That's exactly the way it's shown in the build series. But after it comes through, leave a little gap and put a short length like this on the primary wire that comes across. You can actually see how far I've got it here, and you'll put both your primary wires into that piece of shrink and shrink it down, of course, and that just helps protect it. The underside of this board in particular, but both PCBs, should make sure you trim back any of the little leads that come through, so that there's no really sharp edges that can wear their way through the choke wires or the primary wires. Now you're looking right now at the low voltage region, 120 volt AC mains, but the build series shows you how to make up these wires. That's pretty much identical. The new IEC here is pretty self-explanatory. You're going to have your hot leg will come here, so that goes through the fuse, and your return path goes here where it's not labeled, just like this, and your ground, of course, is the green lug over here.
So all the extra wiring that we show for the original IEC that looks like this, you don't have to do the extra loops around or connections on here. No. It's all done internally for you here.
Yeah, so it's a huge advantage. Now, the ground should be soldered. I prefer that today. And you can see here we're using a little heavier wire. This is 18 gauge. So you'll have a yellow with a green stripe on it. That's for your ground return pass. And it comes from here where you're going to solder it. That's the only wire that will come on to this lug and get soldered. And make sure that this is done properly. So let me just show you quickly. You want to strip back a really good length, and then you want to come through and you want to turn it back. So let me just get that.
So you have a good mechanical and a good solder connection at the same time.
Yeah, it's very important that the grounds are, especially the safety ground, are done properly. So that's what it would look like. You put a little flux on and you come in and you solder that thing on really well. Okay, and that's what it looks like when it's finished. And it bolts down here to the IEC safety ground bolt. This is your primary return path for the entire amp right here. Okay, the other ground topology change that we made is that we're not coming over here anymore. Even though this works just fine, this is a little bit more of an improvement, so that we always had this, made use of this bolt here. That's just the same as it is in the build series, but now we not only have the transformer ground wire coming to here, but we also take the power supply ground. So this is the center. You can see here it's marked with a G and a grounding symbol. So we take more of that. I just grabbed a little tiny piece of 18 gauge. We take more of this grounding wire that we use, and it comes from the center bolt here, and it sneaks around to this bolt here. And we connect this one up the same way, another wire, and over to here. And that's it for changes in the power supply area. Okay, let's move on. So we're now taking a look at the new version 4 PCBs. The basic layout is almost identical. So where the hookup wires come is all in exactly the same place. I always forget to turn this one particular junction around. In fact, when I rebuilt this whole preamp, I think for the second or third time.
Maybe even the fourth.
Yet again, I forgot, and I put this facing the other way. And you can wire it up that way, but it's much smarter to come in this way. It's much, much better. It's the natural way. So just remember that the one blue junction that doesn't go facing out is this one, the power supply ones. These two here. And you can see, here's jump 1. So here's your signal coming in to the PCB. And there's jump 1 right here. So right now it's engaged. So we actually have the bypass in. But of course, if we wanted to have the capacitor C1 in circuit, we would just pull it out. It's just as simple as that.
If you're doing this after running the amplifier, make it safe. Discharge the capacitors before you do anything inside of here.
Yeah, now if you don't have a discharge, Charles, why don't you go grab the discharge tool? I'm pretty sure the build series we talked about this, but
just in case. So here's a simple discharge tool. Here, let me just scroll it through the camera here. It's fairly long, and that's on purpose.
It's got a 10-watt resistor in here that I think is probably 120 ohm or something like that, and all that does is slow down the discharging of the big filter capacitors so that you don't get too much of a spark.
So all we're doing is we're taking this end to where our high voltage supply is, and we're taking the other end to a ground point, preferably the IEC ground, and we're just shorting out that high voltage to ground through a big resistor, and that discharges all of it.
Yeah, and it makes safe. Now, before you go into the amp, even after you discharge, you should take your voltmeter, set it into DC, and let me just move us back a bit, and you should clip on your ground over here, and you should probe the B plus here and here. You will probably see a couple of volts, but so long as you're below 10 or 12 volts DC, you're safe to work. Of course, you've already unplugged the IEC cord, right? Yeah, everybody knew that. Okay, so what do you do if you don't have a discharge tool? Well, the simplest thing to do is to set the amp up in its normal operating condition. So just turn it on, lamp the filaments, turn the high voltage on, let it warm up for a couple of minutes, and then turn off the high voltage and just leave it for a half an hour or an hour. And what'll happen is the tubes are still lamped. And when you turn the lamps off on the tubes or the filaments off, they will have actually drained the power available in the amp.
Mm-hmm. As long as the tubes are lamped, they're still completing the circuit. They're still allowing current to flow through, and they will have a steady discharge as if the amp was still running. So
if you take care of that the day before you're going to work on it, or let's say a couple of hours before you're going to work on it, then you can go ahead and unplug the IEC cord, unplug the tubes, turn it upside down, get the bottom plate off of it, and then you can take your voltmeter, set it into DC, and you can check your voltages, and you should find that you're well below 12 volts DC. You probably will only see 1 or 2 volts DC, at which point you know it's safe to work on. Make sure you check both sides, because this is a true dual mono design. So there's literally 2 preamps inside of the chassis. So there's 2 power supplies.
Yeah, and the 2 filter stages are completely independent. So discharging one will not discharge the other.
Yeah. Okay, so that's great.
Let's go take a look at these PCBs, and we'll show you a couple of tricks on putting them together.
Okay, so the one big change, other than possible component position changes on the preamp PCB, is that we've put jump 2. We were talking about that earlier. This is the cathode bypass jump. This is it right here on the finished PCB. And I'm going to show you, in the build series, I show you one way to install the jump, and I'm going to show you another method that I use typically in my builds these days. Okay, let's get the soldering iron turned on, and we'll be right back. Okay, so let's get all organized. So I've got the soldering iron set for about 370 C, which is about, I think, 695 Fahrenheit. It's a little hot, but the reason why it's going to be a little hot is because we're going to get in and out very quickly. So you can see where jump 2 goes. Let's get a little bit of flux on those 2 square pads. And we're going to clean our tip, and we're going to preload it with some solder. I'm going to drop this in.
It's a little easier to do whenever you don't have to show off to the camera.
Yeah, nothing ever works when you're filming. Okay, now, one of the tricky parts about these jumpers is getting them in so that they actually stand vertical. So try and get it close to vertical, but don't fuss, because I'm going to show you how to fix it if it's not.
And watch where you're pressing down on the leads here, because you are touching those leads with a hot soldering iron. Don't burn yourself.
Yeah. Now what you want to do is make sure you've actually got it pressed against the PCB, and you're just going to come in and you're just going to tack it.
A second. That's all you're on there for.
So even though I'm actually got a finger on that lead, I'm not going to get burnt because I'm in there so quickly. Now take a look and see if you're reasonably close to vertical. If you're not, what you do is you just get your finger on the pin that's not soldered, and just heat this up and just wiggle it over slightly. It only takes a second, and then check it. If you've got it, now you can come in and you can finish it up. And now life's a lot easier. So we've got one pin that's unsoldered, and we're just going to come in, and it won't take long, and boom, Bob's your uncle. Now, sometimes when you tack components on, you actually don't get a good solder job on that first tack. It's enough to hold it in place, but it needs to be finished soldered. So as soon as that second pin is cooled, you can actually come back in and you can just rework that slightly and put a drop of solder on, and boom, Bob's your uncle. Let's take a look at it now and see what it looks like. And that's pretty close to vertical. So don't fuss with it. It doesn't have to be absolutely perfect. Somewhere close is good.
You just want it fairly flat to the board, and you don't want it canted off to the side by 30 degrees or something.
Now, if you use this method, as opposed to the one that we show in the build series where we just lay the board like this and solder it like that, be careful if you're holding these pins, because you are going to be applying heat, so you cannot hold the soldering iron on here for any length of time. You're on and you're off quickly, and then you won't suffer a burn if you do it that way. Mm-hmm. And I found this to be actually the quickest and easiest way to put small components on. Now,
you might be wondering, why don't we just put the jumper on top of it and hold it with that? And you can do that, but the problem is that these aren't attached to anything yet. These pins are still, they're kind of floating in the plastic. And if you try to put the jumper on, you actually have a chance of just pushing it right through here if it's not mounted to anything.
Yeah, and you could possibly deform the jumper as well. So best not to install the jumper. Mm-hmm. Okay, well done, everyone. Okay, the last thing I'd like to show you is a little bit about mil-spec soldering techniques. So in the build series, I talked a bit about that it's not absolutely necessary to solder both sides of the board, and that is still true. But when I do pro builds for customers, I always try to do a mil-spec soldering job, and I'm going to show you the basics of what that means. So let's just put in one of these R2s, the 470K 2 watts. So I've already checked it, and let's just get it on the board, and it's going to go right here, and let's see if I've got a good fit. Not too bad. And because there's almost no power on R2 at 470K, we don't need to lift this resistor off the board. But I will show you some of the components that I like to see lifted off the board, and we'll do those in just a minute. Okay, so let's get that schematic out of the road. Now, I tend to solder a little hotter than we normally recommend in the build series just because I do this a lot. So I've got it set at, soldering iron set at 370 C, 695 Fahrenheit. You might be a little bit lower or a little hotter, depends on your soldering iron and your tip.
Or you might be like me and like to run it up around 400.
Yeah, well, Charles is younger, he's faster. I think he's less patient. Are you less patient?
I also use very, very high quality solder with a lot of flux in it.
Yeah.
So that helps.
Okay. So we're going to hold for a second and let that flow out, and then we're going to come over here. We'll do the other side. Sometimes it seems like you need three hands or 3 sets of fingers. Someday, if we ever meet up with an alien humanoid-like race, I'd be willing to bet you they've got an eye in the back of their head, an arm mounted to their back somewhere. No, you don't think so?
Probably not.
Okay, so let's just straighten that out a little bit so it's nice and neat. And you can see here we got really excellent flow through on the other side. That makes for a good mil-spec job. It means that these double-sided pads, which they actually have, the trace goes right through the hole. So it connects up on both sides of the board.
It's tinned right through, and now it's actually filled with solder right through on both sides.
But it didn't flow through here. And that doesn't mean we did a bad soldering job, it just means it didn't flow through. But what we can do is we can come back to the other side of the board, and we can just solder it like a normal pad. And there we go. We just clean that up like you normally would, and Bob's your uncle. So that is a mil-spec soldering job. And of course, we're going to snip the leads in a second. Okay, let me show you a couple of components on the power supply board I'd like to see stood off. I'll be right back. Okay, so why don't we install one of the diodes, and I'll show you how I prefer to install them these days. The current draw of the universal preamp is really extremely low, so this is really not required, but I've found over the years that I like to bring best practices to every component, and maybe, you know, it'll give us a slightly longer lifespan, who knows. But if you can do it and it costs you next to nothing time-wise, it's not a hassle, then why not? So I like to get hard-working components on the board off the board slightly with a little spacer. I use some little strips of wood. I've got, you know, a huge selection of them all the way up to this monster that I use on one of our big power amp kits that needs to get a big resistor way off the board up into the air. And what this does is just allows the temperature coefficient of the component in here to the silicon diode to actually be the same all the way around, and that just helps give you a longer lived component.
If you don't have a little wooden spacer, I like to use one of these little spudging tools.
Yep.
It has a bit of a taper to it, which allows you to adjust that height. But you can use a wooden skewer, any sort of thing that's like that.
Yeah. What you don't want is to put anything in here that's highly flammable, so just be careful of that. So with the component in place, now I would do pairs of these, of course, but with this component in place, I'm actually got my finger on it, I'm holding it up. Now I'm going to bend it over fairly firmly so that it'll stay put, and then we're going to solder it on just like we normally would. So what you're really seeing here are tips and tricks of the pro builds, and years ago we didn't build kits for customers, and we found we were getting more and more requests from customers who just didn't have time or really weren't sure of their build skills, and they were willing to pay us to do the build for them. And now we do quite a few of them actually for customers, and it's all part of the store, of course. So the same thing, I'm holding for a second and I'm going to let go. The smaller the component, the less you hold, right? Because you don't want to put too much heat into something really small like this and damage the component. They're designed to take heat, but not forever. And look at that. We got basically perfect flow through. Let me get that right up on camera. If we didn't, though, we would come and just touch it up with a little bit of solder on the other side of the board. Normally when I do the other side of the board, I'm already clipping these leads off, because what happens is otherwise they might push the component out of position. So I would turn it over like this now, and I would touch that up. Okay, what about a bigger resistor? So let's just take a look here. We've got the dropping resistor that's in the filter circuit as well. R1, 300R, 2 watt. That's a hard working resistor. I'd like to see that up off the board as well. And R1 is right here. And Charles has marked these carefully. So you can see there's a circle. That tells you that that lead has to be connected. And depending on whether you're a 1 watt, 5 watt, or 10 watt, that'll depend on where you drop your resistor into.
Now we're using a 2 watt here, but it's actually going to fit just fine in the 5 watt spot with just a little bit of a longer lead on each end.
Yeah. So we're going to do a bit of a longer bend like that. Let's hope I get it right the first time. It's pretty close. It's pretty close. I think it's going to work. It does. And again, I'm going to use this spacer. How much you space off doesn't matter too much. Something like that. In fact, why don't we grab the caliper and we'll show people. We always have a couple of them on the bench. The spacer I'm using is
only 1¼ millimeters. Yeah.
Yeah.
It's not much.
And this is the smallest one I ever use. Let's switch it over to Imperial for people. And that is 0.05 of an inch, let's say. So not very thick. But, you know, it could be a little bit more, and that would be just fine. And we space it off and we install it just like this. And the same thing, you could just go ahead and solder that on like that, using the same methodology. On the preamp boards, there really isn't a component on the board that's really working hard. So there's no real necessity to space anything off on your preamp board. But the power supply, yeah, we like to overspec and a little bit of spacing. And is it absolutely necessary on a preamp like this? Probably not. So this is just a slight improvement to the build that, you know, we can do easily and inexpensively, and it costs us next to no time. So why not?
Okay, well, I think that covers all the upgrades with the version 4 of the preamp.
Yep, and let's just go over one important detail before we say goodbye. And that is, you need to work from your actual schematic and your component value and follow the actual PCB labeling, because it's correct. I've actually built the version 4 upgrade start to finish to make sure that there's no hiccups, and it's absolutely perfect. So the schematics are what you go by for component placement. Same with the power supply. Follow your schematic as you go with the build, and you'll be just fine.
And if you're still confused, drop us a line. We'll be happy to help you out with it.
Yeah. So have fun building, everyone, and drop us a line when you've got your preamp in your system. We always love to hear what you think of the sound. This is Jim.
And Charles.
Signing off. Cheers, everyone.